Have you ever been out somewhere and you hear it? That sound. You don't even need to see the car. You just know it's a Ferrari. It's a sound that doesn't just roar, it sings. So let's get into it and figure out exactly what makes that engine note so iconic.
And yeah, that's really the big question we're tackling, isn't it? Why does it sound more like a finely tuned instrument than just a pile of moving parts? Because here's the thing, that sound is no accident. It's not a byproduct of making a fast car. It is a deliberately composed symphony, engineered with incredible precision. All right, so where does a symphony even begin? Well, it starts with the rhythm section. In this case, it's the engine's mechanical heartbeat. This is the core component that sets the entire tempo for everything else. And this is the secret sauce, this single plain crankshaft. Now, this is not what you'd find in your typical V8 muscle car. Nope, this design comes straight from the world of high-performance racing. Its flat, 180-degree layout is the absolute foundation for that signature Ferrari scream. This table really lays it all out. See, a standard V8, the crossplane one, has this irregular firing order. The exhaust pulses from the engine are literally bumping into each other in the manifold. That interference is what creates that classic, deep Doro-Doro rumble. But the Ferrari's single-plane crank? It fires perfectly evenly, just back and forth between the two cylinder banks. There's no interference, and that lets the engine sing with a pure, clear, high-pitched voice. The Japanese language has the perfect word for this sound, kuun. It just perfectly captures that feeling, right? It's not a rough guttural growl. It's a smooth, almost soaring sound that just climbs and climbs in pitch as the revs go up. And that is a direct result of those clean, even explosions.
And on the flip side, you have Doro Doro. This is that muddy, low-pitched rumble we were talking about, where all the exhaust pulses are colliding and getting jumbled up. It's definitely powerful, don't get me wrong, but it just doesn't have that musical clarity. So right there, the physical structure itself dictates the entire foundation of the sound. But okay, a clean rhythm is only half the battle. That's the beat. Now we get to the really cool part, how that beat gets turned into a full-blown melody. This is where Ferrari's engineers stop being just mechanics and, honestly, start acting like composers. And they do it by controlling something called harmonics. So think about it like this. When you pluck a guitar string, you hear the main note, right? But if you listen closely, you can hear other, fainter, higher-pitched notes layered on top. Those are harmonics. And if you can control which of those harmonics get amplified, you can literally turn engine noise into a musical chord. And this is exactly how they do it. It's brilliant. The engineers specifically design the shapes of the intake and exhaust systems to resonate at very specific frequencies, usually the third and sixth harmonics. When you layer those frequencies on top of the main engine note, you get a rich, complex, and really pleasant-sounding chord. They are literally tuning the engine like it's a flute or a pipe organ. And get this, in the modern cars, they even install something called a hot tube that pipes only the most perfect frequencies directly into the cabin, just for the driver to enjoy. Incredible. Okay, so this is all fascinating for a multi-million-dollar supercar, but can you actually apply this stuff in the real world? Well, absolutely. Let's take a look at how motorcycle nuts try to chase that same iconic sound on their own bikes. The whole process really boils down to three key things. First, you've got to start with the right foundation. And for that high-pitched sound, a four-cylinder engine is usually the way to go. Then it's all about obsessing over the exhaust system. And finally, picking the perfect silencer. And here are the tricks of the trade. You use thinner exhaust pipes, because that makes the exhaust gas speed up and faster gas equals a higher pitch. You install equal-length headers. Sound familiar? It's the same principle as the Ferrari's crankshaft, just preventing those exhaust pulses from messing with each other. Then you pick a straight-through silencer to let those high notes really scream, and you build it all out of a thin, hard material like titanium to get that sharp, metallic ring. Of course, and this is a big but, chasing that perfect sound doesn't come for free. Every single engineering choice has a consequence, whether you're building a hypercar in Italy or tinkering in your own garage. Yeah, these mods come with some very real-world trade-offs. For instance, when you tune an exhaust for that incredible high-pitched scream, you often lose low-end torque. That means the bike might feel a bit sluggish off the line in city traffic. A loud straight-through silencer? Sounds amazing for sure, but it could also get you a not-so-friendly chat about noise regulations. And of course, exotic materials like titanium sound fantastic, but they cost a lot more.
And all of that brings us right back to what makes the Ferrari so special. It's not just about being loud or high-pitched. It's about crafting the final, perfect composition through the incredible art of acoustic engineering. I mean, think about it. Ferrari has entire teams of acoustic engineers. From the very earliest design stages, the sound of that engine is being calculated and perfected in computer simulators. They're carefully choosing frequencies that our brains literally associate with speed and excitement, while at the same time, they're filtering out any ugly vibrations or unpleasant noises. This is not a happy accident. It's pure calculated science.
So if you take away just one thing, let it be this. The art of the Ferrari sound is really this perfect fusion. It's the combination of the engine's physical structure giving it that clean, even beat, and the musical approach to tuning that gives it a rich, emotional melody. It's really where physics meets music.
And that kind of leaves you with a final thought, doesn't it? Our world is absolutely filled with engineered sounds. Think about the satisfying click of a button on your phone, or the gentle chime in your car reminding you to buckle up. Those weren't accidents. Now that you know how it's done, what other sounds in your life do you think are designed specifically to make you feel something?